Okay, in this video we'd like to look at proving the law of cosines. The law of cosines is useful for solving triangles where you know two sides and the included angle, or where you know all three sides and you like to find some of the angles. So I've started with just a generic triangle, ABC, and I'm going to drop hypotenuse, or altitude, sorry, from C down to AB. Now what we're going to be doing here in this law of cosines is we're going to try to use the Pythagorean theorem, because the law of cosines is actually just an extension to the Pythagorean theorem that goes from, instead of just a right triangle, it works for any triangle. And so you may notice over here I have this little right triangle here. And so what I'm going to do is try to use the hypotenuse A and the two legs of that right triangle. And using those, along with the Pythagorean theorem, we will generate the law of cosines. Now the first thing we need to do is I want to express everything as far as sides as much as possible in terms of angle A, because angle A is the side, or angle opposite side A. So we begin by looking at this side D right here, which I've highlighted in orange. D is one of the legs of this triangle, with angle A. Now what do we know about D? It's the adjacent side. We also happen to know the hypotenuse of that triangle. It's B. So using our basic information about trig functions, we can say that the cosine of A is equal to the adjacent of the hypotenuse, and from that we can solve for D. You can get that D is B cosine of A. Now D is not actually the side I'm interested in. I'm interested in this other side over here, which I'll highlight in green and call E. Now E is just equal to side C, the big long side, from A to B. Take away side D. And so that, since we know what D is, it's B cosine of A, we can say that E is C minus B cosine of A. So now we know side E. So now the blue line I'm going to label and call M. M is the height of that triangle, and again in terms of angle A, we know that M is the opposite side in that right triangle. So we can say that sine of A, is equal to M over B, from which we get that M is B sine of A. I know what you might be thinking here. Wait, this is called the law of cosines. Why are we bringing in this? Why are we bringing in the sine? Well, it turns out the sine's going to actually disappear a little later on. So now we know the two sides, or the two legs of my triangle, and they're both expressed in terms of angle A. So we know this leg now, and we know this leg. And so now by the Pythagorean theorem, we can figure out what A has to be. Well, A squared would be equal to M squared plus E squared. Now we know that M is B sine of A, so when you square that, you'll get B squared sine squared of A. And then E is C minus B cosine of A. So it would be C minus B cosine of A, all squared. And now we just start to work things out. So just rewriting that piece, And now I have c minus b cosine of a squared. So I'm just going to multiply that out. So I have c minus b cosine of a times c minus b cosine of a. When I do that, I'll have c times c will give me c squared. Then I'll have c times b cosine of a. And then I'll have another c times b cosine of a. So I actually have two of those, minus 2cb cosine of a. And then I'll have b cosine of a times b cosine of a. They're both negative, so they become positive. And we'll get plus b squared cosine squared a. Now I'll have a b squared in two of those terms. B squared sine squared of a and b squared cosine squared of a. So I'm going to put those two things together and factor out a b. And then everything else I'm just going to leave on there. So c squared minus 2bc, just rearranging the letters there, cosine of a. Now what is sine squared a plus cosine squared a? Well, that's our Pythagorean theorem, our Pythagorean identity. So, once again, Pythagorean theorem jumping in a second time here. That's equal to 1. So now we can summarize it and put it all together. A squared is equal to b squared plus c squared minus 2bc cosine of a. And that is the law of cosines. The law of cosines actually has three forms. You can also say that for b squared, or for side b, b squared is a squared plus c squared minus 2ac cosine of b. And you can say a similar one for side c. Now that's the proof, and that's what it is. Well, we'll take a moment now and show you exactly what this visually looks like. So what the law of cosines is telling us now is we have an old triangle ABC, and we know two sides, AC and AB, which we can label as B and C. If we know those two sides and the included angle, angle A in this case, then we can find the third side, which we can call A. And so if we know the orange, the green, and the blue, then we can find the black, which is side A. And so that's visually what the law of cosines is telling us. Or alternatively, if we know all three sides, the black, the orange, and the green, then we can find angle A, blue angle there. And so that's the law of cosines, and again, how the law of cosines actually works. Okay. So again, just one last quick look at our law of cosines.